a basic point that I want to start with is this claim at the top of the slide, that sanitation is everybody's business. And I mean that in two senses. In one sense, we're realizing that sanitation is not just an infrastructure issue anymore, not just the province of engineers. In fact, it matters for gender issues like we were talking about. It matters for health. It matters for nutrition and human capital. Although I won't be able to really talk about it today, it turns out to matter for educational achievement and for child learning. Because if you have good health in early life, then that helps you achieve more in school. It matters ultimately for economic productivity, because all of these early life things matter for adult human capital. And so sanitation is everybody's business in the sense that everybody needs to be worried about it. Another sense in which sanitation is everybody's business is that even if you use a toilet or latrine, in India, there are going to be people around you who don't, because more than half of the people in India defecate in the open without using a toilet or latrine. And population density is very high, which means that there's an open defecator, close to you at all times. And so it's not just something where you can say, my family uses safe sanitation, so we're okay. In fact, it's everybody's business. But today, here at 3IE, we're going to be talking about a field experiment that happened in Maharashtra. And I've been asked to give a policy-oriented, non-technical presentation. So if you came here hoping for Greek letters and regression equations, I'm sorry to say I'm going to disappoint you. But I hope that, nevertheless, I'll have something interesting to say. I'm going to start by talking about why I'm talking about this. Why are we talking about child height at all? Why is that an outcome that we care about? And it turns out that the answer is going to be because it's a window into what goes on in early life. And early life is a very important time. So this figure is from the DHS, from the NFHS, from a big survey about health and nutrition in India. And so it's representative of children in India, and what we've plotted here is the average child height for age. So height for age is a measure of how tall children are relative to a healthy population, right? So they've formed a healthy reference population of children, 1/6 of which are from right here in Delhi in India, and they say how tall are children growing at each age relative to that group. And so these are all negative numbers, which means that kids in India are too short relative to healthy children. If you only learn one thing today, that's an important thing to learn. Right? But you see it against age and months here, and what you see is that all the falling relative to the healthy population happens in those first 2 years of life. And so that's really going to be why height is so important, because it reflects what goes on in health and net nutrition in the first 2 years of life, when you're growing. So every now and again I go on a diet, and I don't eat so much, and I go running, right? And sometimes the diet works, and I get a little bit less fat. But so far, it's never happened that a diet has caused me to get any shorter. And, right? Okay, that was a joke. That's a lot of points, right? And so the reason is because my height was determined in early life. It's too late, right? So when we're looking at the average height of a population, we're learning something about early life health and net nutrition. But it's not just height that's developing in early life. Brains are growing, bodies are growing, so many things are going on. And so on average, people who have better health and net nutrition in early life are more likely to grow to their physical potential and more likely to grow to their cognitive potential. And that means on average in a population, taller people have more cognitive achievement. Now you have to say on average in a population, right? My wife, Diane, she's ever so slightly shorter than I am, but she's much smarter than I am. So you can't just compare people. You have to think about, but at a population level, it's very important. So let me show you how important it is. This graph shows this same measure of height for age against whether or not children can read. And these gray lines are from children from the United States. And it's a very famous result. It got published in a famous economics paper showing just how upward sloping that line is. I want to get back here to the back of the room so I can see it like you. Can you see how upward sloping that is? Well, you can't, I guess. I guess I messed up. Because what I did by accident there is I put it on the same axis as the same line for Indian children. And the slope is so much steeper for Indian children that you can't even see it, the US slope. So children in India who are taller are much more likely to be able to read and recognize numbers. And that means that relative to more developed countries, in a place like India, early life health and net nutrition is an enormous determinant, relatively, of cognitive achievement. And that matters, throughout the life cycle. It matters when children grow up and become workers. So all throughout the world, wherever we look, we find that taller people earn more money. So here's an example of Tom Vogel's work for Mexico. In fact, that's why economists even started thinking about height as an economic variable, because it's such an important measure of human capital. So, what we know is that if we know something about the average height of a population, then we know something important about human development. And, I would love it if we started using height instead of GDP per capita or something like that. And it turns out that we already have some interesting reasons to think that sanitation is important for height. And I just told you that height's an important measure of human capital and human development, right? But perhaps the ultimate measure of human development is GDP per capita. And there we have a great big puzzle. Because it turns out that GDP per capita and height across developing countries have basically nothing to do with each other. So each circle here is a country. The bigger the circle, the bigger the population of the country. So like here's India here in South Asia. I guess that one's Turkey. This is from a paper by Angus Deaton. And so here you have GDP per capita, and here you see the average height of adult women. And what you see is no relationship whatsoever, right? No association between GDP and height. And what's even more surprising is, India here at the bottom is even shorter than people in sub-Saharan Africa. And these are adult women. It'd be even more strikingly true for children today because there's been so much economic growth since these women were born. So there's something that's been called the Asian enigma, which is a big puzzle. How could it be that children in India are so much shorter than children in even poorer countries like sub-Saharan Africa? Well, there were a lot of things that go wrong for early life health in India. It's what my friend Parma Menon calls a perfect storm. The status of young mothers and all sorts of things that are bad. But the one I'm going to focus on today is about sanitation and open defecation because child height is such an outlier in India. It turns out that open defecation is an outlier in India too. Not only do more than half the people in India defecate in the open, but more than half of the people in the world, 60% in fact, of the people in the world who defecate in the open live right here in India. India is the world's capital of open defecation. It's basically been eliminated from China and Bangladesh and much smaller fractions in sub-Saharan African countries. So this picture from UNICEF and the WHO shows different regions of the world, right? So here's South Asia, here's sub-Saharan Africa. And it shows it in 1990 and 2010. And what you can see is that open defecation is helpfully color-coded at the top. And we can see that not only is there more open defecation in South Asia, and remember that's basically India, than in sub-Saharan Africa, there's more open defecation in South Asia in 2010 than in sub-Saharan Africa in 1990. We're more than 20 years behind. So it really is an Indian exception, an Indian outlier. And maybe it can explain the outlier of Indian height. And sure enough, when we compare DHS data across countries, we find it can. Now each circle here is a collapsed DHS survey. Each circle is a collapsed DHS survey. And so here's India's 3 DHSs in 1992, 1998, 2005. And we have this same measure of average child height for age, right? So all negative numbers. And here's open defecation, right? So the fraction of households who defecate in the open. And what we see is a strikingly good line for real-world econometric data, an R-squared of more than 54%. Variation across country years in open defecation can account for more than half of the variation in average child height. But notice here that India is right on the line. So it's not a puzzle in this sense. It's exactly what's predicted given the international trend. And you can add a bunch of controls. I won't get into it now, and the line basically doesn't move at all. And it's not just that open defecation is bad for you. It's that it's bad for you when you encounter it. So what would be particularly bad is open defecation in a densely populated area. So here I've taken these same 140 circles, but instead of having the fraction of people defecating in the open on the horizontal axis, I have the open defecation density, the density of people defecating in the open per square kilometer. And so what we can see is that it really looks like it's no surprise that kids in India are so short, because they're exposed to this double threat of high population density and open defecation right here at the bottom of a really striking international trend with a really tight fit. So that's all motivation to make us think that open defecation might be something very important. We've seen in data sets of lots of types showing this relationship. We've seen it in well-identified econometric studies looking at change over time. We've seen it in economic history data looking at the fact that when did populations in Europe get taller? Not when they got more food, but when the disease environment got better. But what we'd really be interested to see is a randomized controlled experiment and see when sanitation gets better, do children get taller, right? And by how much? So I'm going to be talking about a field experiment that was organized by the World Bank Water and Sanitation Program in 2004 that Jeff Hammer, my co-author, was really the leader on, and that I merely inherited the data to like a decade later, right? So somebody other than me did all the hard work. All I did was do the statistics and write that. So what was supposed to happen in this field experiment And it's going to be an interesting story, this field experiment. We're going to learn something about field experiments from the story of what happened. It was an experimental collaboration between the Government of Maharashtra and the World Bank. So this was at the very beginning of the Total Sanitation campaign. So the TSC, the Total Sanitation campaign, which built latrines and motivated people to use them by painting things on the walls and having events, right? It sort of lost to history exactly what happened in these cases. But what we know is that since the TSC hadn't happened everywhere yet, the government agreed to randomly pick the villages that they did it in as an initial rollout. And so they did 3 survey rounds. They collected baseline data in February 2004. They did this village level intervention in some villages and not others. And then they collected midline and endline data afterwards to see what happened. And the original idea, at least what the World Bank thought was going to happen, was that it was going to happen in 3 districts of Maharashtra. So within each district, there'd be 60 villages, 30 treatment, and 30 control. And it happened in these 3 districts, right? And so the World Bank contracted with data collection firm to collect data in 3 waves in 3 districts because they were going to need the data, right? And the only outcome they were interested in, they said from the very beginning, we want to know about the effects on child height per age. They said, diarrhea is terrible to measure in surveys, mortality, there's no way we're going to have a big enough sample. We're focusing on child height. And like we said, it's a very important measure. That's what was supposed to happen. But it turns out that somehow the wires got crossed. Or maybe the Government of Maharashtra and the World Bank didn't communicate, or maybe somebody changed their mind. And they ended up only doing the experiment at all within 1 district, Ahmednagar district. That turns out to be the richest and highest human development of the 3 districts. The one where you might think the program would be most likely to work. The other 2 are poorer, have a larger scheduled tribe population, much less female literacy, lower population density, right, which we've already seen matters. And so, I think there's something interesting here to reflect upon, which is that experiments happen only where experiments can happen, right? You need an organization that can implement it. You need them willing to be able to do it. You need an appropriate context where people think something's going to work to be willing enough to put themselves out on the line. And it turns out there's a bit of a miscommunication here. And the government was really only willing to do it in Ahmednagar. Now, lucky me as the economist that they randomly, they had a separate set of villages within each district. And so they randomly assigned the treatment and control within each district. So we have randomization, internal validity, and everything within Ahmednagar. We can imagine a researcher just reporting on the experiment that happened in Ahmednagar, right? And saying, okay, I have a randomized controlled trial in Ahmednagar. Why even talk about the other 2 districts? Because in most cases, they wouldn't even bother to collect the data in the other 2 districts, right? Once you knew there wasn't going to be an experiment there, fine. You're not going to collect the data there anymore, right? Only because the World Bank happened to have already written this contract do we even have any data on these other 2 districts. You just read your experiment paper and it would say, we did a randomized controlled experiment in Ahmednagar, blah, 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 randomized, blah, 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 right? But in fact, we know the places where it could have happened but didn't. Okay, so were there any effects? So now we're just going to be looking at that paper. We're pretending I only wrote a paper about Ahmednagar, right? So I only wrote a paper about 30 villages, treatment and control in Ahmednagar. What are the effects on child height? Well, they got more latrines. Here's the part where I'm skipping all of the Greek letters. And so if that's what you came for, again, I apologize. But we saw that they got more latrines. We have a bit of an independent check that something happened, and that the central government's Clean Village Prize was more likely to be won, over the course of the next decade by the 10 villages in the treatment group and the control group. And I think there's probably not very much contamination there, just because you'd be expecting a lot of these agencies to had their act together and coordinate. And so we know, we have reasons to think that, there really was a sanitation program in the treatment villages in Ahmednagar by more than in the control villages in Ahmednagar. And when we look at child height, we sure enough see an improvement. So this graph is showing the difference in average child height per age between children in the treatment villages and children in the control villages. And the dark line is before the program, and the light line is after the program. And so first, in the Nandurbar districts where they collected the data anyway, even though there was no experiment, it's zeros in both cases. No surprise. That's what we would hope would happen, conditional on them not doing the experiment. But I don't know exactly what to do about that. But if that weren't there, you could see that in Ahmednagar, there was a 0 before the program, and afterwards about 0.2 of a height for each z-score difference. And 0.2 of a height for each z-score difference is the sort of difference that one sees in this literature. That's a large and important but plausible effect that one sees in the literature of the effects of things on height for each z-scores. And it's actually very quantitatively comparable to effects we see from other identification strategies, things with discontinuities, things with fixed effects, the international thing. So it looks like there's an effect in Ahmednagar. Now, just to be clear, it doesn't get children anywhere near as tall as they should be. Here's the treatment group, and here's the control group, and here's this reference mean of healthy children, right? So we have a long way to go, and nobody here is saying that sanitation is the only thing that matters. I mean, nor that this program completely, perfectly improves sanitation. But there did seem to be an effect. So now we have some reason to believe, from a, causally rigorous way, that improving sanitation really did make children grow taller. So what can we learn from this? Well, there's a long debate in economics about the trade-off between internal validity and external validity. So internal validity is about cause and effect, right? Have we really learned about cause and effect? Do we know that our treatment actually causes our outcome? And external validity is about whether or not it's generalizable. We've learned from this case, but as a policymaker, I have to make a decision about that case. And does this case actually tell me about that case? And so we know there's a trade-off there, but we don't know how big of a trade-off it is. And it's ultimately a quantitative question, right? If I'm the Joint Secretary for Rural Sanitation, I care about how sure we are about cause and effect. Does my program really have an effect? And I care about how generally applicable are these results, right? How much is it going to tell me about the next case of what I'm going to do next? And I started out showing you some non-experimental evidence, the DHS data, right? And there's all sorts of non-experimental evidence, actually, linking sanitation and child height. And my personal judgment is that those studies are pretty generally applicable, and that we can be reasonably sure about cause and effect, right? Not as perfect as one might hope, but it seems to be a stable effect that we see over and over again. So how good or bad is experimental evidence? Do we greatly increase our being sure about cause and effect without really giving up the general applicability? Or do we lose a lot of general applicability in the quest to learn something about cause and effect? It's an important question because experiments in many cases are special cases, right? They only happen where experiments can happen. Well, like I said, it only ended up happening in one district, right? Well, so every experiment only ends up happening in one place, right? The only thing that's special about this case is that we happen to know the other places they considered where it didn't happen. But it turns out the place that it happened, although you can't read it, are better in a lot of human dimension rates. Lower open defecation to begin with, much lower, like 20 IMR points, lower infant mortality to begin with, higher human development, better female literacy, all sorts of things going on that are good in the Ahmednagar, right? So reasons to think that government programs are more likely to work, maybe, or more likely to be delivered, and reasons to think that if you're going around giving written messages on walls or talking to moms about this is going to make your children healthier, which is what the TSC did, maybe either women are going to be more empowered to act on it, or to understand it, or to believe you, all sorts of reasons to think there might be a special effect there. And so, what we do to try to assess the extent to which there is this internal validity, external validity trade-off is we see, in what's called a triple difference, what the effect interacts with, right? And it turns out that it interacts with these human development measures, that the effect is bigger in villages that, for example, have higher female literacy. Now, that's not the same level of causal correctness as the randomized experiment itself, right? That's just an ex post facto interaction. Nobody had even dreamed that we would be running that regression when they did the original experiment. And I'm not here to tell you that the TSC only works in villages with high female literacy. It's just an example, right? But it turns out that if we fit the model to the data and then predict what the effect would have been in Ahmednagar, where it really happened, we basically match the effect. And then if we predict what the effect would have been in the two places where they didn't do the experiment, we predict that the effect, with their much lower levels of human development, and maybe that's about government effectiveness in those places, would have been a lot smaller, right? So the place that we saw the experiment happen is, we saw a much bigger effect than the effect that our data predict that we might find, we don't know, but that we might find in 2 places where the experiment didn't happen. And I guess I want you to go back and say, there's nothing, every experiment happens in only one place, right? Every experiment, or only one set of places, right? And even if you were to replicate and say, okay, now we're going to do this in a different country or a different state or whatever, there's going to be some process, some bureaucratic political process by which the place is decided, by which the government of Maharashtra says, no, we don't want to do it in those 3 districts, we want to do it in this 1 district. And it's a quantitative question how much that costs you. And it's going to be different in different cases. And I think it's just worth reflecting on what this story might teach us about by how much the effect of estimates in the literature is shaped by the unobserved processes that shape available experimental contexts. So there's a way to sort of answer that question in the best case scenario. In the best case scenario, you have tons of field experiments and you compare from the answer in different places. Now, like I said, it may be that every time they're choosing the best place, but let's look for other field experiments in the literature. Well, it turns out that's hard to do. It's hard to learn about the effect of sanitation on child height experimentally. And that turns out to be because it's hard to actually create an effect on sanitation to learn from. It's easy for governments to build latrines. Latrines are something that you own. But what actually makes people healthier is latrine use, and that's something that you do. And that turns out to be very hard to change. So whenever you want to do an experiment to learn the effect of, whenever you want to learn, let's say you want to learn the effect of sanitation on child height, right? You actually have a 2-stage problem. First, you have your treatment. And you need your treatment to change open defecation, right? So that's what econometricians call the first stage. And then you need that change in open defecation to cause a change in child height, right? And so what you're wanting to learn about is the effect of open defecation on child height. That's what we really care about, not, the details of something that we'll never know that happened in Maharashtra 10 years ago. We care about the generalizable question of what's the effect of open defecation on child height. But if we're ever going to learn that, we have to have a first stage effect of the treatment on open defecation. And these 2 parts might be bigger or smaller in different places. For example, in India, there's every reason to believe that the effect of open defecation on child height is going to be particularly large compared with other places like sub-Saharan Africa where population density is very low, right? In places where population density is high, there's reason to expect this second stage effect to be really big. But it turns out that it's also hard to generate a first stage effect in India, just because open defecation turns out to be such a stubborn behavior in India. So I looked up the very small set of other randomized controlled or other well-identified studies of effects on open defecation in India, and they're all sort of getting small effects on first stage effects on sanitation of like single-digit percentage points. So we saw about an 8 percentage point effect. Yanev Stopnitsky's great paper about the No Loo, No I Do program on brides in Haryana saw about a 4 percentage point effect. There's another WSP paper of Paul Gertler and co-authors in MP that sees about 10 percentage points. And from another paper of mine looking at the TSC, I also see about 10 percentage points. So the first stage effect on sanitation is very small. And that seems to be more so true in India than in other places. So it may be that it's very hard, if we go around saying, we don't know the effect of open defecation on child height until we have a great experiment that's perfect in every way. It may well be that open defecation has a large effect on child height. And in fact, we have reason to think so. It may be that it's very hard for us, and field experiment after field experiment shows it, to induce this first stage effect on open defecation, perhaps especially in India, right? And so for my last little bit, I want to carry that reflection forward and ask about why it might be the case that it's so hard to reduce open defecation in India. And I'd like to urge, going forward, thinking about what the implications of this, that we really turn our attention to how can we reduce open defecation in India? What sort of experiments can we start doing? What sort of studies, experiments, randomized controlled trials? Let's launch a wave of studies figuring out about that first stage. What sort of treatments are going to reduce open defecation? Because even if I haven't persuaded you that open defecation is everybody's business and that it matters for so many things, and I hope I have, but even if I haven't, the new government has committed to ending open defecation by 2019. So that's the policy of this country. Let's help them figure out how to do it. It turns out in India, this is a great challenge because there's lots of open defecation, more than half the people in the country, right? Most of the people in the world who do it. There's high population density, so we go pound for pound. Open defecation is particularly costly, and it turns out, like I showed you in those 4 bars, it's really hard to get people to stop defecating in the open. Other countries have eliminated it. India hasn't, despite economic growth, right? The simplest economic principle of revealed preference suggests that maybe people in India have a preference for open defecation. It turns out the problem may even be getting worse. We saw evidence earlier that it's the density of open defecation, open defecators per square kilometer, that might be the most important exposure for health. But the decline in the fraction of people defecating in the open in India has been so slow that it's been outpaced by population growth. And most people in India, 53% of people in India, live in a district where the density of open defecation increased between the 2001 and 2011 censuses. Most of the decline has been in big cities like Delhi and Chennai and Mumbai. So, in fact, most people are exposed to more than before. And all these states that are orange and red are states where even at the state level, the density of open defecation has increased. So with a team of collaborators, including Nidhi and Nikhil, we just wrapped up what we call the SWOT survey that was, just asking about people's beliefs and preferences and what they think in these red states, in these states where open defecation has gotten worse. And, what we're trying to do with this survey is 2 things. One is separate latrine ownership from latrine use. If you look at the census data or the DHS data, it's at the household level. And they say, like, does this household defecate in the open? Does this household own a latrine? But it turns out open defecation is a thing that you do. And that means that different people in the same household might do something differently, and that's going to be a blind spot of data at the household level. And finally, we're just going to do a thing that economists usually hate to do, which is ask people about their beliefs and preferences. Why do you do what you do? And it turns out that people are perfectly happy to tell us that they like to defecate in the open, and that they think it's actually perfectly good for your health. So, back to that principle of revealed preference. It turns out there are many, many toilet owners, many people living in households who have a toilet who nevertheless defecate in the open. All over the news these days is access to toilets. So we've got to increase access to toilets. Well, maybe access isn't the only problem. Maybe there are lots of people out there who have access and still don't use it. And one of the ways we can see that is by looking at this figure. So this is at the household level. So these are all 3,600 households that we talked to. And more than half of them, everybody in that household defecates in the open. And about a quarter of them, nobody in the household defecates in the open. But what I think is interesting, and that the census data and DHS data can't tell us about, is in 18% of these households, some people defecate in the open and some people don't. And that means that there's a working latrine that people could use, but are not. And in fact, 48% of the households that we surveyed in Bihar, MP, Rajasthan, and UP had a working latrine, right? That some people in the household used, but some people in the household did not. So those are people who have access to a latrine and still aren't using it. And, that tells us something important about the policy challenge. It's not all about access. It's importantly about people's preferences and what they choose to do. And if we focus our policy response on access, then we're going to miss out on changing the behavior of folks. And keep in mind, these are not randomly assigned latrines, right? These aren't the random latrines in Maharashtra, right? These are the latrines that people somehow endogenously ended up with, either because they bought them or because a government program offered it to them and they accepted it. And frankly, not everybody does, or they dismantle it or use it for something else, or they turn it into not a latrine, right? So in a sense, this is like a best case scenario insofar as this is 48% of the households that have consented to have a latrine, right? And there's no reason to think that if we go around giving the rest of the households a latrine, it's going to be even this good. So we have a lot to learn about why people were defecating in the open, even though they have access to a latrine. And one of the things that we need to learn about is the demographics of it. So this shows, only looking at households that have a working latrine, the fraction of people who defecate in the open, who are females and males at each age group, right? And so we see, no surprise, males at every age, except for children, are more likely to defecate in the open than females are. The people who are more or less the least likely to defecate in the open are young, bahu age, daughter-in-law, young woman, age women. And except for the oldest people who, more or less, have difficulty going outside, right? we see a cohort effect where older people who are socialized in older cohorts are more likely to defecate in the open despite not having a latrine. And I think we see something important that, like, even in this demographic group where open defecation is least likely, right? So 15–20% of young women in households who have a latrine defecate in the open. That looks good for India, but that's terrible in international comparisons for whole populations, right? 4% of all of Bangladesh defecate in the open. There are dozens of sub-Saharan African countries where the whole country's open defecation rate is lower than the rate for the best demographic group in rural India where they own a latrine. Right? So all of which is to say we have much to be learned, much remains to be learned about why this happens and needs to be part of the policy discussion going forward so that we're not just building latrines that people don't use, but actually changing people's minds about it. So, this is my last slide, and I'll stop talking. Personally, no randomized controlled experiment can tell me this, but what I believe needs to happen is a latrine use revolution. That it's not just about building latrines, but getting people to use it. And I'm optimistic that with the new government, it might be something that's led from the top. Because what we just saw is that building latrines alone is not going to end open defecation. A lot of them are going to go unused, and a lot of them are maybe never even going to get built, despite the allocation, that there's nobody local who actually wants it and makes sure the money gets spent. I didn't talk about it, but we have a lot to do in terms of helping change people's minds. Because a majority of the people that we interviewed who defecated in the open were perfectly happy to tell us that they thought that children would be no healthier in a village where everybody used latrines than in a village where everybody defecates in the open. So I hope that we can start a campaign of experimentation and learning, randomized controlled trials and other types of learning about what works, an active campaign visible at all levels, like what solved the problem of polio in India, right? This is going to be even harder than polio and even more important. More babies die from open defecation every year in India than died from polio every year all the way, not even died, got polio all the way back in the 1980s, right? There's every reason to think this is a larger cost and a harder problem. So we need to be approaching it with the exact same campaign mindset. And I hope that we can see leadership from the very top in the new government, that Modi's next wave can be to lead a social revolution to wash away the normal open defecation. Thanks so much. I look forward to your questions.